In this video, we're going to deal with compound sample space. Simple sample space, remember, dealt with simple probability, which was one fraction. Compound, on the other hand, just like with compound sentences, deals with more than one fraction. So what this means is you could have two fractions, which is normally what we will see in 7th grade. But you can have 3, 4, 5, 10, 100 different fractions, and all of those are considered a compound probability. So what we're going to do here is to create a tree diagram, which we talked about that with the simple sample space. Kathy is buying pizza for dinner. She has the choice of getting thin or pan crust. She needs to make a choice between pepperoni, sausage, or ham for the toppings. Draw a tree diagram to show all the possible outcomes or combinations of crust and toppings. So the first thing we start with is the type of crust. There's a thin crust and there is a pan crust. So now that you have those two types of pizzas, this is the first probability. It's the first outcome, the first event. Compound probability, on the other hand, deals with more than one. So the second set of events is the pepperoni, or is all the toppings that we have. So we have 3 different toppings, ham, sausage, and pepperoni for the thin, but those also come over here, ham, sausage, and pepperoni. This right here is where the compound comes in. It is a tree diagram. So it creates branches. So the number of outcomes right here, when we are dealing with this, if all you do is you count the last set of branches. So I have 1, 2, 3, 4, 5, 6 possible outcomes when dealing with compound probability. I have a thin ham, thin sausage, thin pepperoni, that's 3. I have a pan ham, pan sausage, and pan pepperoni, that's 3 more, so 6 altogether. Alright, the second type of sample space you will encounter when dealing with compound sample space is a table. We kind of addressed this with simple probability, but it's kind of hard to do it with simple probability, so here's how we do this with compound probability. Suzanne has a number cube and a quarter. Create a list of all possible outcomes for the rolling of the number cube and the flipping of the coin. So, on the coin we have a heads and a tails. So that is for the coin. Those are the sample space for the one coin. For the die, we have a 1, a 2, a 3, a 4, a 5, and a 6. Those are the possible outcomes for the die. So all together, when we do this, we could have a heads 1, a heads 2, heads 3, so on and so forth, just combining everything. Now, had this been a simple, I could have just stopped there, and I would have had 6 outcomes. But because this is compound, I now have to do a second set of events. So when I count all these, all you do is you just count the individual squares. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes with this compound sample space. Now, some of you may have already been saying, hey, wait, I think I figured something out. There are 6 outcomes on this die. There are 2 outcomes on this coin. Can't I just multiply those together and I get 12? That is exactly what you do. So that's also another thing. If they just ask for what are the outcomes without having to build a picture or anything, you can just do the 6 times 2 to get 12. Alright, the last set that we're going to deal with is a list. Now, this list right here is going to be slightly different than a table. When you're building a list, it's just like when you would list out a grocery list. I need bread, I need milk, I need soda, whatever the case may be. So here, when we do this, I recommend starting with one of the events first. So we have our die and our quarter again. So I'm going to start with the heads option on the tail. On the coin, I can have a heads 1, heads 2, heads 3, heads 4, heads 5, and heads 6. I can also have, so starting a second row because I'm going to run out of line, for my tails option I do the exact same thing. 3, tails 4, tails 5, and a tails 6. Now this is slightly different from a table. Notice I don't have any options on the top telling me what they are, options on the side. This is just a list of stuff, so that's why I separated it all out with commas. Again, if we look at this and count up the total number of combinations, there are again 12 different outcomes. So again, sample space for compound probabilities, you have to combine both sets of events. They want to know what's the possible outcomes for both of these different events happening. So these are the different types of compound sample space that you will see in 7th grade.